Okay. So today we are going to start with May-June 2020, paper 2-1. Let's start with question number 1. Yes, gallium is a metal in group 13 of the periodic table. Okay. There are two stable isotopes of gallium 69 and gallium 71. State with the reference to subatomic particles how the isotopes of gallium 69 and gallium 71 differ from each other. So, as you know, this value is the mass number, right? Or you can say nucleon number, and nucleon number is equals to protons plus neutrons. And if you see, the proton number is always the same. So it means that uh, as they ask you with the reference of subatomic particles, how the isotopes differ from each other. So they are differ from each other due to the different number of neutrons in them. So I'll write over here, they differ from each other due to different number of neutrons in them. Is this clear? Okay, I don't, my screen is having some problems. Let me reshare it. Okay, now, next part. State what further information is needed to calculate the relative atomic mass of gallium. So if we have to calculate the relative atomic mass of any element, we need two things. One is, if you recall, the isotopic mass, and the isotopic mass are present over here. One isotope has a mass of 69 and the other isotopes has a mass of uh, 71. So whenever we have to calculate the relative atomic mass, so if you guys recall, relative atomic mass has the formula that sum of isotopic mass times their percentage abundances divided by 100, isn't it? So the other information that we need is the percentage abundance of each isotope. Is this clear to all of you? Okay. Now, next part. Gallium and its compounds show similar properties to aluminium and its compounds. One minute. There is some issue in internet, that's why screen freezes, so I have to reshare it again. Okay. So gallium and its compounds show similar properties to aluminium and its compounds. Gallium reacts with excess chlorine to form gallium trichloride. Okay. At 500 degrees Celsius, gallium trichloride is a gas. Suggest a type of attraction that exists at 500 degrees Celsius. Okay. So if you recall, if if it's a gas, then which type of bonding it is, or which type of substance it is? The covalent or the ionic? Covalent. Very good, Hassan. So it's a covalent. So it means that gallium trichloride is a covalent, GaCl3, right? Now, suggest the type of attraction that exists at 500 degrees Celsius between the atoms within a gallium chloride molecule. So if I make a gallium chloride molecule, it's like this, right? So this is the attraction, and this attraction is called, yes, covalent bonding, Fatma. Very good. Why, Shre, induced dipole? Induced dipole is always between the molecules. So right now they are asking between atoms within a gallium trichloride molecule. So it means they are talking about this. And this is a covalent bond. Is this understandable to all of you? Whether you are talking about this or this or this, all of them are the attraction between the atoms within the molecule. So it's a covalent bond. So here I will write covalent bond. Now, next part, between gallium trichloride molecules, it means this is the one molecule. And if we, for example, I have another molecule over here. So how these two molecules are interacting with each other. So there must be a force of attraction between them as well. And that is called temporary dipole-dipole forces or induced dipole-dipole forces. Yes, very good. So, Hassan, is this clear to all of you? So I will write over here induced, or you can write temporary as well. So induced dipole forces. Now, let's move to the next part. When gallium trichloride is cooled, a solid Ga2Cl6 forms. So see, they have given you a hint over here, if you recall. See this, read this statement. Gallium and its compounds show similar properties to aluminium and its compounds, isn't it? So if you recall this, we have studied the same compound of aluminium in our syllabus, which was Al2Cl6. And what we call it? We call it dimer, which means 2 units when two AlCl3 molecules combined with each other, isn't it? Now, suggest the name of the attraction formed when two gallium trichloride molecules to form Ga2Cl6. Yes, can anyone recall when Al2Cl6 is formed from two AlCl3 molecules, which bond is formed? Very good, Ishal. Coordinate bonding. Very good, Shrey. Coordinate bonding. So see, they have given you over the hint over here. So whatever properties or whatever things you have studied for aluminium, you are going to apply those things over here. So the answer would be coordinate bonding or a dative bonding for this part. Is this clear to all of you? So either you can write coordinate bond, it is also correct, or either you can write dative bond, it is also correct. Okay. Now, let's move to the next part. Gallium metal reacts rapidly when exposed to air. And when they are talking about air, which substance they are referring to? Okay, Aniza, you are talking about, okay. Yes. we will move to that thing. It's oxygen. Very good, Shrey. Yeah, Fatma, very good. It is because, see, they are molecules, right? And Anisa, they have been asked between the molecules. So remember, between the molecules, there are intermolecular forces. And if you recall GaCl, if you see GaCl, gallium, GaCl3, gallium is in group 13 or group 3. So how many valence electron? It has 3 valence electron. And if it has a 3 valence electron, so around this, there is no lone pair over here, but 3 bond pairs. And if this is the case, then the shape would be trigonal planar. And if the shape would be trigonal planar, then see all of the ends have chlorine in it. So it's a, if all of the ends have a same atom, so it means it's a non-polar molecule. And between the non-polar molecule, there is always a induced dipole-dipole forces. And when there is a polar molecule, then between the polar molecule, the forces of attraction would be, permanent dipole-dipole. Okay. Okay, now let's move to this part. A white solid layer is formed on its surface. Suggest an equation to describe the reaction occurring when gallium metal is exposed to air. So see, that's what happened with the aluminium as well. And we get the layer of aluminium oxide, Al2O3, right? So that same thing would happen over here, that gallium forms gallium oxide, and you have to write the equation. So let's write it. Gallium, Ga, is reacting with oxygen, O2, forming gallium oxide. So if you recall, see, the formula would be same for gallium as well because gallium is in group 3. So how we would make the formula? Gallium is in group 3, so it forms a ion with a 3 positive charge. Oxygen is in group 6 or group 16, have a charge of 2 minus. So what we will do to make the formula, we will move the value of the charges to the subscript of the opposite atom. So it would become Ga2O3. So I will write Ga2O3, gallium oxide. So now I have to balance it. Either I can balance it. See, there are 3 atoms over here of oxygen and there are 2. So I will put a 3 over here, making it 6, right? And for that, I will put a 2 over here. So oxygen balanced on both the sides. Now I will, there are 4 ox gallium over here on the product side. So I'll put a 4 over here to balance the gallium on both sides. Is this clear to all of you? Okay. Now, the table gives the formula of each gallium containing product formed when gallium oxide reacts separately with the hot aqueous hydrochloric acid and hot aqueous sodium hydroxide. So if you recall the nature of the aluminium oxide, it's amphoteric, isn't it? It reacts with sodium chloride and base and acid as well. So this gallium oxide would be the same. It reacts with both, you know, acid as well as base. So it's a amphoteric oxide. Okay, just give me a minute, please, everyone. Mm. Okay. Give the name of the type of behavior shown by gallium oxide in these reactions. So see, if it is reacting with both, so its behavior would be amphoteric. So I will write over here amphoteric. Is this clear to all of you? Okay. Now, next part. Question number 2. The equation shown in A1 describe the reaction which occur when aqueous potassium iodide is added to aqueous copper 2 sulfate. Okay. A white precipitates of copper 1 iodide forms in a brown solution of iodine and potassium sulfate. Okay. So balance the equation and include state symbols as well. Okay. So if you see, mm, so how we will balance this equation? Okay, if you see over here, how many iodine we have? 3. And over here, only 1. So the best way is to make the iodine on the right even. So if I put a 2 over here, now these 2 iodine becomes 2. Oh, sorry, not 2, 4. And for that, I will going to put a 4 over here. Is this clear to all of you? Now, potassium gets 4 over here. To balance these potassiums, what I'm going to do, I will going to put 2 over here. So now see, the iodine is balanced. Now potassium got balanced. So by putting 2, this sulfate becomes 2 over here and this sulfate is 1 over here. So I'll put a 2 over here. This makes the sulfate balanced on both the sides. Till here, is this understandable? Okay, Fatma, you did it. Okay, yeah, very good, perfect. Now, and here it is going to be 1, right? Now we have to put the state symbols as well. So see, when aqueous potassium iodide is added to aqueous copper 2 sulfate, so it means this is going to be aqueous, this is going to be aqueous. Then a white precipitates of copper iodide, so it means copper iodide would be a solid, forms in a brown solution of iodine and potassium sulfate. So see, both are the solution, so it means both are going to be aqueous. So see, this is how we make the state symbols. Is this clear to all of you? Okay. Now, the table gives the oxidation numbers of iodine in different species in the equation. Okay, in potassium iodide, iodide is -1. In copper iodide, it's -1. In iodine, it's 0. Reduce the oxidation number of copper and copper sulfate and copper iodide. Okay, so if we work over here as we did in redox, there is no charge over here, so it means sorry, my screen is again stuck. Let me read. Okay, am I audible to all of you? Okay. Yeah. So we have to find the oxidation number of copper in copper sulfate and copper iodide, right? So see, if we work over here that there is no net charge, so it means it's 0. and we know that the sulfate is -2. So if the sulfate is -2, then it clearly indicates the copper must be +2 over here. Now, in the next one, so here I'm going to write +2. In the next one, the net charge is 0 because nothing is written, and iodide is -1. From here, I can identify it. Otherwise, you can look at the periodic table. Then the net charge is 0. So it means that the copper over here is going to be +1. That's why we are getting the net charge 0. So over here, I'm going to write +1. So that's what we have studied in redox, how to find the oxidation numbers. Is this clear to all of you? Yes, you are taking Benin oxygen individually. I took the whole sulfate because if you recall, we have studied the polyatomic ion. This whole thing has a -2 charge, so I took that only. I didn't go for a sulfur and oxygen individually, okay? Yes, did you understand, Benin? Okay, now, next part. Describe the type of reaction shown by equation in A1. Explain your answer in terms of electron transfer. So if you see that copper is +2 and copper gets +1 over here, right? From +2. So it means a gain of electron occurs, which means reduction. If you see over here, potassium is -1 and potassium turns into a 0 over here, which means loss of electron occur, which means oxidation. So both reduction and oxidation is taking place. So it means it's a redox reaction. Yes, very good, Hassan. It's a redox reaction. Is this clear to all of you? Okay. Now, next part. In a reaction described in A1, okay, this one, okay. Okay, let me write the equation over here. It was 2 moles of copper sulfate reacting with 4 moles of potassium iodide, forming 2 moles of copper iodide with 1 mole of iodine and 2 moles of potassium sulfate. A student uses 17.3 gram of copper sulfate, and it's a hydrated copper sulfate, right? Because there is a Y moles of water of crystallization along with the formula of copper sulfate. By further titration, the reaction products, the student concludes that the total number of copper sulfate in the sample is 0.0982 moles. Okay. So only anhydrous copper sulfate moles are 0.0982. Use the data booklet to complete the table to calculate the value of y, where y is an integer. Okay, so see the data booklet concept is in the previous past papers from 2022 onwards. Now there is no concept of a data booklet. Instead, the values are given along with the table, along with the question, and the constants and the periodic table are always at the end of the paper. Okay, so what they are asking over here, mass of copper sulfate. So these are the moles. If you recall the formula of mass is equals to moles times mr. So the moles are 0.0982. We have to calculate the mr of copper sulfate. So can anyone tell me from the periodic table what I recall the mass, the AR of copper is 63.5, sulfur is 32.1, and oxygen is 16. So we have to oxygen, we have to times it 4. So can anyone add them and tell me the answer, please? It's 159.6. Okay, thank you, Shri. So 159.6 multiplied by 0.098, 0.0982. Can anyone tell me the answer when we multiply these two, what we will get? It's 15 point. Okay, it's 15.67. Now, amount, see the next part, amount of water in 17.3 grams of this. So what we will do, we got the mass of CuSO4 only, and this is the mass of CuSO4 dot YH2O. So we have to just do the subtraction. So 17.43 minus 15.67 will give me the mass of water, right? It's 1.76 grams. And they are asking for the moles of water. So what I need to do, I have to divide it with the MR of water, and the MR of water is 18. So divide it with the 18 because hydrogen is 1 and oxygen is 16, and there are two hydrogens, so it becomes 18. So it's 0.097. Okay. Yeah, that's what we did. We divided with the MR of water, 18. Okay, Hassan? Okay. Now we have to find the value of Y. Okay. So see, if I do the ratio thing, CuSO4 has Y moles of H2O. So if there is a 1 mole, then how many moles of H2O? Y moles we don't know. But if the moles of copper sulfate are 0.0982, for that moles of copper sulfate, we have 0.097 moles of water. So if you will cross multiply, you will get the value of Y. So Y is equals to 0.097 divided by 0.0982. Can anyone solve me and tell me the answer, please? Okay, so we are getting 0.0, no, 0.99 or 0. Yes, it would be for sure, Fatma, round off to 0.987, 0.996. Okay, so 1 mole. So 0.996, which would be round off to 1 mole. So the value of Y would be 1. Till here, is this clear to all of you? Okay. Now, let's move to the next part. Next question, it's question number 3. Nitric acid HNO3 can be made by reacting nitrogen dioxide with water. The enthalpy change for the reaction can be measured indirectly using Hess cycle. Okay. Explain what is meant by the term enthalpy change of formation. So you see, you guys need to remember the definitions. It is the enthalpy change when 1 mole of a compound is formed by, yes, very good, Ishal. Very good, Fatma. Elements in their standard states, and there is no need to mention the standard conditions because they didn't ask you for the standard enthalpy change, right? So for the, if they have asked you to write the standard enthalpy change, so you must write under standard conditions from its elements in their standard conditions, in their, sorry, in their standard states. Yes, not conditions, because the conditions would be standard if they ask you to write standard enthalpy change of formation. Till here, is this clear? Now, B part. Complete the Hess's cycle using the values given in the table and hence calculate the enthalpy change delta HR for this reaction. Okay. So, see, formations are given, and for, if you recall, formations are the equation has a elements turning into compounds, right? That's this kind of a reactions enthalpy change is called enthalpy change of formation. So here, if you see, all of them are compounds. So what I'm going to do, I'm going to put the elements over here. So there is a we need nitrogen, we need hydrogen, we need oxygen. These three, right? So nitrogen and oxygen reacts with each other to form nitrogen dioxide, and hydrogen and oxygen reacts to form water. So I'll put one arrow to the left showing the formation of 3 moles of nitrogen dioxide and 1 mole of water. Is this understandable? And then make one arrow towards the left showing 2 moles of nitric acid and 1 mole of nitrogen monoxide. Okay, just give me a minute, please, everyone. Yeah, 1 minute, please. Okay, now if you see the definition, in definition we have mentioned how many moles of compounds are formed. 1 mole of a compound are formed. 1 mole of a compound is formed, right? It's, let me reshare it. So 1 mole of a compound is formed. If you see 3 moles of NO2 are formed, so it means that its value would be times 3. 1 mole of water is formed, so it would be remains times 1. 2 moles of nitric acid are formed, so its value would be times 2. And 1 mole of NO, so it stays 1. So here I'm going to put 3 times 34.0 plus minus 286 only. And here I'm going to put 2 times minus 173 plus 91.1. Yeah, is this clear? Because this is over here and this is over here, so that's why I put their values on the left. And this nitric acid over here and nitrogen monoxide over here, so that's why I put their values on the right. Okay, Banin, let me check. So if you see the direction of the arrows, these two are, this is the 2 step and this is the 1 step. So remember, always 1 step is equals to the 2 step. So if I'll make the equation would be 3 times 34 plus minus 286 plus delta HR is equals to 2 times minus 173 plus 91.1. If I keep delta HR on one side and move all of the values on the other side, so it would be, the expression would be like this, would be minus 3, 34.0, and minus plus makes it minus as well. So minus 286. So can anyone solve and confirm it? uh, Whenever you can do the direct, there is a, always a problem in doing the direct. Sometimes you will use the wrong formula, so you will get the wrong answer. So it's better, remember, whenever they have given you the formation over here, Mariam, you will put the elements over here and make the arrow from the elements to the compounds and put these values and solve it like this. Shrey, you are saying minus 88.9. Banin, you are saying minus 70.5. I suggest both of you to redo it. So see whose answer is correct and if someone do any mistake. And can anyone else also recheck this? Here, Hassan? Okay. Yes, Shrey, check it again. And Banin, you also check it again. Okay, Hassan, you are getting minus 70.9. Shrey is minus 70.9. Okay. So Banin, you also did the correct thing, but I think you only took any value wrong after the decimal. That's why you are getting minus 70.5 and you are not getting minus as well. Yeah, it would be minus. Shirey, yours is negative or a positive? Negative, okay. Hassan, yours is also negative. Why, Banin, why you are getting positive? It's negative. Check again. So it's minus 70.9. Okay, yeah. Okay, Banin. So till here, is this clear to all of you? Okay. Now, nitrogen and oxygen do not react at normal atmospheric temperature. Explain why. And it's for 2 marks, so you need 2 reasons. So that's what we have studied in the nitrogen and sulfur chapter, the reactivity of nitrogen. If you guys recall, nitrogen has a triple yes, Fatma, very good. But your one answer is correct. Oxygen has a double bond, but oxygen usually react in the normal temperature, isn't it? It undergo corrosion as well. So what if it's non-polar shell? Has a triple covalent bond. Yes, Banin, due to high activation energy and a strong triple covalent bond. So that would be the more appropriate answer. Nitrogen has a triple covalent bond and high energy is needed to break the bond. Is this clear to all of you? Yes, if you write this, that it's a non-polar, so it's less likely to react and has need more energy, then it would considered as a correct. Okay, Ishil? Now, nitrogen oxides can be formed naturally in Earth's atmosphere from nitrogen and oxygen in the air. State one way that nitrogen oxides produced naturally. So, if you recall, yeah, very good, Ishal. Lightning, very good, Hassan. Lightning. So the lightning is the cause due to which these oxides produce naturally. Next part, nitrogen dioxide NO2 act as a homogeneous catalysis in the oxidation of atmospheric sulfur dioxide. Explain why NO2 is described as a homogeneous catalysis. Catalyst, okay. Yeah, the states are they are in the same phase. Very good, Anisa. So I will write homogeneous catalysis, and see it's of 3 marks, right? Means NO2 is in, let me reshare it. Yes, is it sharing? Is in same phase as reactant. It increases the rate by lowering the activation energy and without being changed chemically at the end of the reaction. Is this understandable to all of you? Or instead, you can also write that it regenerated at the end of the reaction. Now, write the equations which describe the two reactions occurring while NO2 act as a catalyst in the formation of sulfur and sulfur dioxide. So if you recall the two reactions, first one is SO2, sulfur dioxide is reacting with nitrogen dioxide forming sulfur trioxide, SO3, and nitrogen monoxide, NO. It's again freeze. Let me reshow it. See, and as NO is formed, so that NO, not NO2, sorry, NO reacts with the oxygen to form NO2 back, and to balance the equation, I have to put a half over here. So this is how the reaction proceeds. Is this clear to all of you? Okay. So with the 4 questions now, no, we are done with the 3 questions, and 3 questions would left, and we are going to do these rest of the 3 questions tomorrow. And tomorrow, do remember the time. We are going to have a class at 4 p.m. PST. Okay. So we'll do the class at 4 p.m. PST tomorrow, and we will continue and try to complete the whole paper tomorrow. Okay. So see you everyone tomorrow. Take care. Good night and Allah Hafiz.